On a circular path of radius 6 meters, a boy starts from point A on the circumference and walks along chord AB of length 3 meters. He then walks along another chord BC of length 2 meters to reach point C. Point B lies in the minor arc AC. Nice, so it's not coming back like this. The distance between point C from point A, we need to find AC. Right, so, lovely question. So what do we know? We know that this is a triangle AOB, where we know the three sides 6, 6 and 3. With that, we can find cos of angle AOB. And likewise, we can say, hey, I can find cos of angle BOC. So we know the three sides. We know A square plus B square minus C square by 2AB is cos C. So we can find cos of this angle, cos of this angle. With that we can find sine of the angle, sine of the angle. With that we can find cos of A plus B. Find cos of A plus B. We know this is 6, this is 6. We can join AC and find AC. We'll do this very methodically. So I'm going to think about this angle. Cos angle BOA, this angle is 6 square plus 6 square minus 3 square by 2 into 6 into 6. This square plus this square minus this square by 2 into 6 into 6, which is 36 plus 36, 72, 72 minus 9, 63 divided by 72, which is 7 by 8. What are we going to do? We're going to find cos of angle BOC. Again, 6 square plus 6 square minus 2 square by 2 into 6 into 6. I want to find cos of this angle. This square plus this square minus this square divided by 2 into these steps. Lovely. This is 72 minus 4, 68 by 72. Which is 17 by 18. Nice. So cos of angle BOA is 7 by 8. Cos of angle BOC is 17 by 18, which works. The smaller angle, cos should be higher. Right? So 68 by 72 is 17 by 18. 63 by 72 is 7 by 8. Right? So nice. This angle, theta, let's say alpha, cos theta equal to 7 by 8, cos alpha is 17 by 18. So sin theta, sin square theta is 1 minus 7 by 8 the whole square, 49 by 64, which is 15 by 64. So sin theta root 15 by 8. I don't have to worry about negative. Sin is positive in that territory. Not minus root 15 by 8 is root 15 by 8. What have we done? 1 minus 49 by 64. Same funda, sin alpha. 1 minus 289 by 324. 24 plus 11 is 35. 35 by 325. 324. Sin square alpha or sin alpha equals root 35 by 18. What do? We want to find cos of theta plus alpha. We look to find cos theta cos alpha minus sin theta sin alpha. That is this whole thing. It's theta plus alpha. Cos theta cos alpha is 7 by 8 into 17 by 18 minus root 15 by 8 into root 35 by 18. Cos of theta plus alpha is cos theta cos alpha minus sin theta sin alpha. So 7 into 17 is 119 by 8 into 18 minus root 15 to root 35. There's a 5 that is common. 5 root 3 into 7, 5 root 21 by 8 into 18. This is cos of theta plus alpha. What is this equal to? This should be equal to 6 square plus 6 square minus AC square by 2 into 6 equals 119 minus 5 root 21 by 8 into 18. With that we can find AC square. We find AC square, we can find AC. Still not done. Let's hang in there. 119 minus 5 root 21. 8 into 18. That's an 18 here. Make it 3. 3. This becomes 2. 2 into 2 is 4. This is 2. 6 square plus 6 square is 72. I'm going to call AC as x. 72 minus x square into 2 equals 119 minus 5 root 21. 144 minus 2x square. 144 minus 2x square equals 119 minus 5 root 21. 119 minus 5 root 21. Take the 2x square that side, bring this to side. 114 and 144 minus 119 plus 5 root 21 is 2x square. This is 25 plus 5 root 21 is 2x square, or x square equals 25 plus 5 root 21 by 2. This is x square. We need to find x. Still a pain. My gut feel is it's not this, it's not this, it's not this. It's not a number. It should be this. So what I'm going to do, I'm going to root 15 plus root 35 by 2 whole square. So root 15 plus root 35 by 2 whole square, that is 1 by 4 times 15 plus 35 plus 2 root 15 into root 35. 15 plus 35 is 50. 50 plus 2 into 5 into 5, 2 into 5, 10 root 21 by 4, which is 25 plus 5 root 21 by 2, which is this. Proper pain in the neck. We find what is our approach. We look at this question and say, hey, it's going to be time consuming question. We know 3 sides of a triangle, we can find cos of any angle. We find cos of this angle. 3 sides of a triangle, we can find cos of any angle. We find cos of this angle. We know cos of an angle, we can find sine of that angle. This is pure positive territory, nothing to worry. We find sine of theta, sine of alpha. We know cos theta, cos alpha minus sine theta, sine alpha is cos of theta minus alpha, theta plus alpha. So from there, we methodically find cos of theta plus alpha. You get this. Cos of theta plus alpha is this angle. Now we introduce AC and then say 6 square plus 6 square minus AC square divided by 2 into 6 into 6 is cos of theta plus alpha. We know cos of theta plus alpha is this number. Equate it and then find AC square. It turns out that AC square is a mess. AC square is some 25 plus 5 root 21 by 2. Therefore, we know the answer is not any of these 3. It should be this. If we square this and check, it turns out fine. That's our answer. Super tough question, time consuming question, used based on the idea of plugging in cos rule, not once, not twice, but thrice. Cos rule, cos rule, cos rule. Plug in cos rule for triangle AOB, plug in cos rule for triangle BOC, get cos theta, cos alpha, get sin theta, sin alpha, get cos of theta plus alpha, then plug in cos rule for AOC. Super tough question.